Hello everyone. This video is about finding unknowns from a continuous function. So the questions will come in two different ways. The question will all either ask about A, where the function has no points of discontinuity, or it asks about A, where function is continuous everywhere, which both mean the same. So you'll either have one unknown or two unknowns in the question. So let's take a look at each type one by one. The first type, you'll be asked to find A, only one unknown, if a piecewise function is given and you are said that there is no point of discontinuity. Okay, what we learn about points of discontinuity of piecewise functions? We learn that if a piecewise function is continuous, then the value of the function is defined at the given point, limit exists at the given point, and the value of the function is equal to the value of the limit, right? If these three conditions are all satisfied, then function is continuous. So the question already tells us that the function is continuous, so all three conditions are met then. So what are we going to do to find the unknown? So we know that limit exists, right? So how do you find the limit in a piecewise function? You check right side limit and left side limit. If they are both same, then function is continuous. So we already know that function is continuous. So we can set right side limit equals to the left side limit. So limit as x approaches to 2 from left of x cubed equals limits as x approaches to 2 from right of right side function is ax squared. Insert 2 for x, so 2 cubed on the left, on the right, a2 squared. 2 cubed is 8, 8 is 4a, divide both sides by 4, a is equal to 2. So that's the value of the unknown. Right? It's pretty simple. If there is less than or greater than condition, you just check right and left side limits, set them equal to each other to find the unknown. Alright? This is an exercise question. Another question. There are many mystery questions about the same situation. You can check them out. Another question involving piecewise function, but this time there is equal to, not equal to condition. It's a mystery question. Equal, not equal to condition. The equal condition will give you the value of the function, remember. Not equal condition will give you the value of the limit. And since there is no point of discontinuity, those two are equal to each other, right? The value of the function is equal to the value of the limit. So let's equalize them. What's the value of the function at -1? It is, okay, we know that f of -1 equals limits as x approaches to -1 of f of x. So the value of the function is given in the question as 1 over 2a. 1 over 2a equals, what's the value of the limit? We don't know, we'll solve. So limit as x approaches to -1 of x squared plus 3x plus 2 over x plus 1. I am not going to check right and left side limit because this is already giving me the limit, the value of the limit. There is no less than or greater than condition, so you don't need to check right or left sided limit. It's already giving you the value of the limit. So it's the value of the limit. When you solve the limit, when you evaluate the limit here, you are going to get 0 over 0 condition, which needs more work. So you do simplification, rewrite the function. So to rewrite the function, you factorize the top, x to 1, so x plus 1, x plus 2 at the top, at the bottom, x plus 1. X plus 1s will cancel each other. So when you insert -1 back, you are going to have -1 plus 2, which is 1, right? So the value of the limit on the right is 1, while the value of the function on the left 1 over 2a. You need a alone, so let's do cross multiplication. So a is equal to 2 times 1, 2. So that's the value of the unknown. Alright? And there is one more similar ministry question. So the first type was less than greater than condition. We knew that limit exists, so we checked right and left sided limit, equalized them to find the unknown. The second type, there was equal not equal condition. In this case, equal condition gives us the value of the function. The not equal condition gives us the value of the limit. We equalize the value of the function to the value of the limit. So we evaluate the limit by simplifying rewriting. We got the value of the limit and set this equal to the value of the function and isolate the unknown. Alright. And another type of the question, exercise question, there are 3 conditions, 2 unknowns. We're asked to find 2 unknowns. So we will check the limit for each condition. So how many boundary numbers we have here? We have -1 and 3. We have 2 boundary numbers. So we are going to check right and left sided limit for both of these. So we are going to check limit as x approaches to -1 from the left, and limit as x approaches to -1 from the right. We set right and left side limits equal to each other for -1. We will also do the same for number 3. 3 from the left should be equal to limit as x approaches to 3 from right. Right? So we are going to do this for both of the boundary numbers. Let's do that one by one. Left-sided limit for -1, it is 2, equals right-sided limit for -1, this middle condition, ax plus b. So a times x, -1, so -a plus b. So I got an equation here. I didn't get a value. I have 2 unknowns, so I got an equation. So do the same for the second number. 3 from the left, less than condition for 3, ax plus b. Insert 3 for x, so 3a plus b equals right-sided limit greater than 3 condition is the right-sided limit, which is -2. So this is another equation. So I got 2 equations. I still have 2 unknowns. How am I going to find the unknowns by using 2 different equations? By solving them simultaneously. So let's remember how to solve system of linear equations. We are going to solve them by using either substitution method or elimination method. Use whatever way you want. So 2 equals -a plus b, the first one. Second one, -2 equals 3a plus b. Okay, if you want to eliminate one of the variables, you should get them opposite. For example, b. One of them is, they're both positive, so if you multiply one of them by negative, you'll make them opposite and cancel them. So let's multiply the second equation by negative. Negative, negative becomes positive, negative, negative, positive, negative. In this case, b's will cancel each other. -a, -3a makes -4a. On the left, 2 makes 4. Divide both sides by -4, so a is -1. So I got an unknown. The other unknown, b, by inserting -1 back into one of the equations, you'll get the other unknown. So let me use the first one. 2 equals -a, which is -1, plus b. So negative negative makes +1. 1 to the other side, 1. 1 equals b. So a is 1, a is -1, b is 1. Okay. So we didn't do anything different. We followed the same methods. We checked right and left sided limits for both of the numbers. Since we have three situations, we have two different boundary numbers. We did the same for both and we got two different equations. We solved the system. All right. Okay, one last question. Said guy 34, and this type came in Wizari 3 times so far. So how are we going to solve this? First of all, as you can see, there's an absolute value. We should get rid of that absolute value first. How do you get rid of it? X minus 2. If absolute value x minus 2 is greater than or equal to 1, so the inside is either greater than or equal to 1 or less than or equal to negative 1. You switch the sign and change the sign on the other side. So from this case, we have x is greater than or equal to 3. From that case, we have x is less than or equal to negative 2 to the other side, 2, 2 minus 1, 1. So let's rewrite that piecewise function. So it becomes x plus 1. The first situation stays same. The second condition, the interval part will change to x is greater than or equal to 3 and x is less than or equal to 1. Alright, now we can solve the question as we did in the previous question. So what did we do in the previous question? We had two boundary numbers. We found limits, right and left sided limits for both of the boundary numbers. We will do the same. Like limit as x approaches to 1 from the left, whose function is x plus 1, is supposed to be equal to limit as x approaches to 1 from right. 1 from the right, 1 from the left is this. Excuse me, I made a mistake. X is less than 1 condition is the second one. X squared plus bx plus c equals limit as x approaches to 1 from right. X is greater than 1 condition is this one, x plus 1. Similarly, I will do the same for number 3. So limit as x approaches to 3 from left. X is less than 3 condition is the left-sided limit, x plus 1. Is supposed to be equal to limit as x approaches to 3 from the right. X greater than 3 condition is the right-sided limit. X squared plus bx plus c. Now let's solve it. So for the first number, when you insert 1 back for x, it's 1 plus 1 times b plus c equals 1 plus 1, 2. Bring 1 over, b plus c is equal to 1. This is my first equation. Second equation, insert 3 back, 3 plus 1, 4 on the left, on the right, 3 squared, 9 plus 3 times b, 3b plus c. Bring 9 to the other side, negative 5 equals 3b plus c. That's my second equation. So I'm going to solve this system. Okay, let's solve it. b plus c is 1 and 3b plus c is negative 5. So c's have coefficient 1. It's better to isolate c by multiplying one of the equations by negative. Let's multiply the second equation by negative. So in this case, c's will cancel each other. Negative 3b makes negative 2b equals 5 plus 1 makes 6. Dividing both sides by negative 2, b becomes negative 3. Okay, that's the first unknown. Second unknown, by substituting negative 3 back into one of the equations, you'll get the other unknown. Let's use the first one. negative 3 plus c equals 1. Bring negative 3 to the other side. C is equal to 4. So that's your second unknown. So it is just like the previous one. We had a piecewise function with three conditions. We had two different boundary numbers. So we found right and left sided limit for both of the numbers and solved the system. We did the same here. The only difference is we got rid of the absolute value first. By solving this absolute value inequality first, we rewrote this condition and we got a piecewise function with two boundary numbers, just like the previous one. We checked right and left sided limit for each number, equalized them, set them equal to each other, and got two different equations. Solving the system, we got our unknown. Okay, we are done with continuity for now.